All right, happy Wednesday, everybody. Okay, so hopefully we are doing okay with logarithms. Again, if you need help, get a hold of me and then I can walk you through some things. Okay, so we are talking about properties of logarithms, which will get us going to being able to solve logarithmic equations. Okay, so let b, m, and n be positive numbers such that b does not equal 1, and b is the base. Okay, so properties of logarithms. Basically what we're going to be doing is what's called expanding, and then tomorrow we will be condensing. So I will show you the condensed versus expanded properties. So the first one's the product property. So we have log base b of mn. It's a product. Now, this completely goes with the rules of exponents because remember that logarithms are equal to exponents. Okay, so in this problem, say we have x squared times x to the fourth, where we have an exponent and an exponent. What do we do with those exponents in order to be able to condense this problem? That's right. We add them. So the condensed version is the sum of the two exponents. Now, it's going to seem a little weird, but products and sums go together. Just like products, and sums go together. So right now, this is a product. We will be able to expand that into, that's right, a sum. So this is going to expand into two logarithms. This is equal to log base b of m plus log base b of n. So right here in the yellow is the condensed version, and this is the expanded version of those. Products and sums go together. Okay, now if we have products and sums, what do you think the quotient property is? Let's do a quick reminder. If I had x to the fifth divided by x to the second, what do I do with those exponents? We subtract. So if I have log base b of m divided by n, how am I going to expand that? Right, with subtraction. So log base b of m minus log base b of n. And then that brings us to the last one, the power property. Say we have x to the third to the fourth. What do I do with these x? Yeah, I just cross it off. There we go. Let me fix it. Okay. What do I do with these exponents? We multiply x to the 12th. So if I have log base b of m to the n, now remember this was tricky. A logarithm is equal to an exponent. So if I have, my goodness, sorry guys, I keep hitting the wrong thing, it's driving me insane. Okay, so this is considered to be equal to an exponent. This is an exponent. We're multiplying the exponents. So you know what it looks like? N times log base b of m. All right, so once again, the yellow version is what's called the condensed version. This green version is called the expanded version. Okay, so today all we're working on is expanding them. Okay, so right now, this is a product. Here's a rule of thumb. As many terms that are in this, that's how many logarithms that you would have that it expands to. Okay, so 7 is a term. X is a term. It will expand into two terms. So I have log base 3 of 7 plus log base 3 of x. That's it. That's the expanded form. Okay, now logarithms and natural logs are the same thing, because remember that natural logs mean log base e, so it's the same rules. So nothing happens just because I change this to a natural log. How many terms do I have? One term. Two terms. How many logarithms should I have? Two. So natural log of 5, its division, minus natural log of y. All right. Now, I only have one term here. Okay, so I'm only going to have the one logarithm on part C. There's only the one term, but it does raise that to a power. Okay, so what happens with this is this 3 simply drops to the front of the logarithm. So if it's a power, it comes to the front. Log 3 log base 4 of x. Okay, so I did one of each example. Now let's put more than one example together. Okay, one term, two terms, but with a power. So it is a product. So I'm going to simplify it. It needs to be expanded into 2 logarithms because I have 2 terms. Natural log of 5, product plus, but that second product has its own rule. That 2 right there, that's a power, so that's going to come out to the front. So the 2 just drops to the logarithm. You know what? Let me redo this really quick. Okay, so that you can see it. So we have natural log of 5 plus the natural log of x squared. I just split the 2 terms. But if one of those terms has a power, you need to use the power rule. So that's where it's going to come to the front. So plus 2 natural log of x. This is the completely expanded version of this. Okay, moving on. We have 7 as a term. 7's a term. Y to the third is a term. And x to the third is a term. How many colors is that? 3. Good job, class. Okay, so that means we need 3 logarithms. 3 separate logarithms. Okay, so I'm going to do this in 2 steps because I'm going to bring down the power second. So I'm going to split apart the 7. Split it from the y. Okay, so log base 3 of 7 plus log base 3 of y, because this is a product. Now this is a division part, so this gets a minus log base 3 of x to the third. So now these exponents need to drop to the front. So my completely expanded version is log base 3 of 7 plus 3 log base 3 of y minus 3 log base 3 of x. All right, now, ooh, tricky. This one can be written in 2 ways. Because I do have this power, it is to this whole thing. So here's the option we do have. We can immediately drop this power to the front. Okay, so that gives me 5 natural log of 3x. But this 5 has to be out in front of the entire piece here. So that will give me 5 natural log of 3 plus the natural log of x. That way I know that the 3 and the x should both be taken to that power. The other option is to say, well, let's apply my exponent rule and say this is the same thing as 3 to the third, or I'm sorry, 3 to the fifth, x to the fifth. So the other way we can write this is this would be natural log of 3 to the fifth plus natural log of x to the fifth, and then bring down the power. So 5 natural log of 3 plus 5 natural log of x, which is what would happen here. You would distribute and distribute. So this is what you end up with. Okay, a couple more. Got 1 term, 2 terms, 3 terms. So how many logarithms do I need? That's right, 9. Oh gosh, funny. All right, just kidding. You need 3 logarithms. Log 4 plus log x squared plus log y. Do we have any exponents? Yes, Mrs. Samuelis. Right, we do. We have that too. So let's bring down the 2. 2 log x plus log y. All right. Now, you do not, if you can just go straight to this step, hallelujah. Good job. Hang on, about ready to. So if you can just go to that highlighted step, good. Okay, you should be able to do that. But if you need to show this other step, please do so. But this is the expanded form. All right, last example. How many do I have here? 1 term, that's a 6. 2 terms is an x squared. 3 terms is the, oh, I wanted a different color. 3 terms is the z. 4 terms is the y to the 4th. How many logarithms do I need? How many colors are there? 1, 2, 3, 4. 4 logarithms. Okay, 4 logarithms. So I have the natural log of 6 plus the natural log of x squared. Now, the z and the y are both being divided. See how they're both in a denominator? Minus natural log of z minus natural log of y to the 4th. All right, once again, these 2 are both in a denominator, so these 2 need to be subtracted. All right, now do we have any powers? Yes, Mrs. Samuelis. Yes, we do. So let's bring those down. So natural log of 6 plus 2 natural log of x minus the natural log of z minus 4 natural log of y. All righty. Okay. You know, it seems like a lot here. You have 5. If we were in a normal class, guess what? This used to be the exit ticket to get out of my class. So you would have had to have done this and written it all out by hand. But now all you have to do is take a look at some multiple choice and clickety click click and answer the questions. And how much longer? 12 minutes. Okay, so we're gonna. I mean, by the time you get through these, maybe you've spent maybe 20 minutes in this lesson. Okay, so, and I've taught it superbly, so you should have no problems. Just kidding. If you have problems, please let me know. Okay. All right, here you go. Problem 1. Go. Blah, blah, blah. Come back. Problem 2. Go. Blah, blah, blah. Problem 3. Go. Blah, blah, blah. Problem 4. Go. Blah, blah, blah. Problem 5. Go. Okay. That is it. So let me know if you have questions. Talk to you later.